Hello guys, welcome to my YouTube channel. Actually, the main reason for is to uh, provide the detailed information about the final project. So I'm here to present my final project presentation of the ADTA 5550 deep learning with big data. So without any delay, let's get into the discussion. So first we need to answer the part one question. The part one question is about using the TensorFlow directly in the coding. Uh, the question is about, is the student required to use the TensorFlow directly in coding? Uh, the answer is yes. The student is required to develop, train and test CNN using the TensorFlow directly in the code for this homework project. TensorFlow, which was covered in the lectures from week 5, week 6, must be used in the AI framework for coding this final project. Coming to the second question, is student required not to take Keras in coding? The final project must be completed using the TensorFlow, not Keras, as it was described in the lectures, and it is important for the final project. There are two sections to this to complete this course. Keras is the main topic of the course first off. TensorFlow is the main topic of the course in second off, which also includes in the final project. So coming to the part two, a data set of image or audio files need to be selected. So here I have chosen the dataset, Vox Celebrities dataset. It is a textual representation file type. The official website is mentioned here. So coming to the report of this dataset, Vox Celebrity is a large scale speaker identification dataset. It comprises audio clips of celebrities extracted from videos on YouTube, and the primary objective of this dataset is to promote the development of speak recognition technique in the real world conditions, which includes the background noises, different accents, and varied recording conditions. So dataset composition, Voxelab has multiple versions, with Voxelab 1 and Voxelab 2 being the most widely recognized. Here is the breakdown. So Voxelab 1 contains over 100k records, 100k records of around 1200 celebrities extracted from interviews, and encompassing a wide range of real-world noise scenarios. Voxelab 2 is an expand version that it contains the uh, million of records with 6,000 speakers. It's the more challenging dataset due to the increase in number of speakers and diversity in audio conditions. So while the core of the Voxelab is audio data, which comes in .avr .m4a format. It also contains metadata that provides information about each audio clip, such as speaker's identity and possibly the source video. This metadata might come in textual format like .txt or .csv. Annotations, Voxelability data comes with annotations that include speaker labels identifying which celebrity or speaker is speaking, and temporal annotation indicating the start and end times of the speech segment. So applications are, Vox Celebrity is primarily used for speaker identification, determining who is speaking from an audio clip. Speaker verification, verifying whether the given voice corresponds to a claimed identity. Voice cloning and synthesis, generating synthesis voices that sound like a particular speaker. And the official source is Vox Celebrities, hosted and maintained by the Visual Geometry Group at University of Oxford. More details and updates and access permissions can be acquired from their official website. I have mentioned that official website URL here. From there, one should navigate to the specific Vox Celebrity project page or associated research papers for detailed information. So researchers and practitioners typically use Vox Celebrity in combination with other audio dataset to benchmark and develop new audio processing models, particularly in speech recognition and real world noisy conditions present in Voxelab make an invaluable resource for the training and robust models. So this is all about that part 2 data set and the data. So coming to the part 3, uh, let me go to the question. So this is about that part 3, obtain Cipher-10 dataset. So the Cipher-10 dataset consists of 60,000 color images in 10 classes with 6 6,000 images per class. There are 50,000 training images and 10,000 testing images. The data is divided into 5 training subsets and one sub dataset, each with 10,000 images. The test subset contains exactly 1,000 randomly selected images from each class. The training subset consists of remaining images in random order, but some training datasets may contain more images from the class than another. Between them, the training dataset contain exactly 5,000 images from each class. So, to answer this question, the student need to do the following uh, task. So, he has to access the Canvas module and go to the datasets section, download all the data files that are available there, and there is a file belong to Cipher-10 dataset. So transfer all the data file into the remote virtual machine. Access the remote virtual GCP using SSH. Open the subfolder JP underscore NTBK in the remote VM. Create a new subfolder under JP underscore NTBK and name it as cipher underscore 10 underscore data. Upload all the data files of the aforementioned dataset cipher10 from the student's local computer to a newly created subfolder in the remote instance. So the steps I followed to answer the question was uh, access the Canvas module. I downloaded the datasets and I uploaded the datasets into the remote virtual machine. So access the remote virtual machine using the SSH. So log into your Google Cloud Platform account and navigate to the Compute Engine dashboard. Click on the name of the VM instances you want to connect. Then click on the SSH button to open the SSH terminal. Once you are connected to remote virtual machine, you should see the command prompt. Type the following command by navigating to the subfolder jp underscore ntbk cd space jp underscore ntbk. So you will be moved to that subfolder. Now create a new folder under jp underscore ntbk and name it as cipher underscore 10 underscore data. Type the following command to create the new subfolder named jp underscore ntbk and name it as cipher 10 mkdir cipher underscore 10 underscore data. So upload all the files of the dataset cipher10 from the student's local computer to newly created subfolder in the remote instance. Uh, so I have provided the screenshot for part 3 for what I did. So here you can see the upload file option here. Click on that upload file option. Select all the Cipher10 dataset files and click on upload files. Then these files will be uploaded into the home directory. Now you have to move these files from home directory to the jp underscore ntbk directory. So just use cp file name jp underscore ntbk slash cipher underscore 10 underscore data. So this command will move all the files which are need to be moved from home directory to jp underscore ntbk directory. So here I have provided the screenshot that I have moved that all the files from Canvas module to jp underscore ntbk cipher10 dataset subfolder. So this is all about whether the 7 files are successfully copied from the home directory or not. So coming to the part 4. So part 4 is about building, training, and testing CN convolutional neural networks on Cipher10 dataset. So coming to the question 4. The student need to provide help to students to while working on the final project. The instructor has created a Jupyter notebook document and provided code to rearrange the dataset, making it similar but not the exactly same. So to the MNIST dataset and ready for use in the project. So the student need to design the convolution neural network used for this project, building, training, and testing the convolutional neural network on the Cypher-10 dataset using the TensorFlow AI framework and Python, training the network with 5,000 steps, and testing the uh, network with every 1,000 steps. So coming to the coding part, here is the coding part for that part 4. So let's give a brief introduction about that Cypher dataset. So the process of building convolutional neural network using Cypher-10 dataset in TensorFlow. The Cypher-10 dataset is a collection of 60,000 rows, 32 by 32 color images in 10 classes with 6,000 images per class. The dataset is split into 50,000 training images and 10,000 testing images. The goal of this project is to train the CNN on training and testing. So coming to the data preparation, the first step in building the CNN with Cypher-10 dataset is prepare the data. We will start by loading the data using TensorFlow TF dot keras dataset dot Cypher-10 dot load data function. This function will automatically download the data if it's not already available on your system. We will then split the training data into training and validation sets using 80-20 split. The validation set will be uh, used to tune the hyperparameters of our CNN. Next, we will pre-process the data by normalizing the pixel values to the range 0 to 1. This is important because this is important to ensure that the data has consistent scale and centered around 0. So here is the coding part about that part 4. So you can see the 5,000 steps added and iterated for each 100 steps. So here is the output of accuracy of that 4,900 step. So coming to the report of the results. So the results of the testing of the model using code are series accuracy values printed out for each iteration of the training loop up to the total of 5,000 iteration. The accuracy starts off low and gradually improves as model is trained. More batches of the data. The final accuracy value is 0.6721. So which is the accuracy of the model on the test set after 5,000 iterations of training. So coming to the report, the above code is training convolutional neural network model on the Cypher-10 dataset. The model is trained on 5,000 iterations with batch size of 100 and a dropout rate is 0.5. The model accuracy is evaluated every 100 steps using the test dataset and results are printed out. The final accuracy achieved by the model is 0.6721. This means that the model can correctly classify approximately 67 percentage of the images in the test dataset. The test accuracy of the model after each 100 iteration is printed out. So the results show that model's accuracy improves over time as the number of iterations increases. Then accuracy starts at a 9.89 percentage and reaches 67 percentage after 4,600 iterations. It's worth nothing that the model's performance could be improved by the tweaking the model's hyperparameters such as the number of layers, the learning rate, and the optimizer used. Additionally, the other techniques like data augmentation, regularization, and fine tuning could also be applied to improve the model's accuracy further. I have also attached the uh, Python notebook file for this project report. So that's all about that part 5. Now coming to the part 6. Uh, Sorry. Coming to the part 5, comparing the convolutional neural network performance. So small introduction. I'll be giving the small introduction about the MNIST and Cipher dataset. MNIST consists of grayscale images of handwritten digits with 60,000 training images and 10,000 testing images. Each image in MNIST is 28 by 28 pixel, and the goal is to classify each image into one of the 10-digit classes 0 to 9. Cipher, on the other hand, consists the color images are in 10 classes with 50,000 training and 10,000 test images. Each image in Cipher is 32 by 32 pixel with 3 color channels. The goal of the cipher is to classify each image into one of the 10 classes, with which includes animal, vehicles, and household objects. Uh, State of the art, deep learning models can achieve very high accuracy on both datasets. For example, on MI and MNIST, CNNs can achieve accuracy up to 99.9%, while on Cipher, the best model can achieve accuracy of 99%. However, there is a high level accuracy that requires sophisticated techniques and extensive computational resources. Compared to MNIST, Cipher is considered a more challenging dataset due to the higher complexity and variability in color, texture, and shape. Cipher requires more advanced techniques and models to achieve high accuracy in classification. So coming to the performance, so accuracy of Cipher, convolutional neural networks of Cipher dataset, which consist of 60,000 color images in 10 classes, 60 with 6,000 images per class. So the code trains CNN using the mini batch gradient descent, which batch size is 50 and total of 50,000 5,000 iterations. So the initial learning rate is 0.01, reduced by the factor of 0.95 every 1,000 steps. The accuracy of the model and the test is printed on every 100 steps during the training. The accuracy on the test set is steadily increases over the course training and reaches finally the 0.6457 after 5,000 steps. This indicates that CNN is learning to classify the images with reasonable accuracy. Although there are still be room for improvement, it's worth nothing that the accuracy can be vary based on the specific random initialization of the network weights and the choice of hyperparameters. So it may not always reach the exact value. So accuracy of MNIST. Uh, so CNN is to classify handwritten digits of MNIST dataset. The CNN architecture is used in this code consists of two convolutional neural networks with 32, 64 filters respectively, followed by the max pooling, dropout, and two fully connected layers. The code trains on the CNN using mini batch stochastic gradient descent with a batch size of 50 and a dropout probability of 0.5. Trained 5,000 steps, and each 100 steps model is evaluated the test score. So comparison, both the accuracies are training convolutional neural networks on different datasets, Cipher10 and MNIST respectively, using TensorFlow. They both train their models for a certain number of steps for printing accuracy and the model on the test set of every 100 steps. However, it is difficult to compare the accuracy of the two models since they are trained on different data sets which have different levels of difficulty. MNIST is a similar data since it contains only grayscale images of handwritten digits, whether Cipher contains color images of various objects. So looking at the output of the code snippet, the accuracy of the Cipher 10 model starts at around 10% and increases steadily reaches 64% after 5,000 steps. On the other hand, the accuracy of MNIST model starts around 10% and will increase it to 99% after the similar number of steps. There it seems that MNIST model is significantly more accurate than Cypher-10 model. However, this is not a fair comparison since the data sets are different. So I have also attached the ACC CNN MNIST Python notebook file and ACC CNN Cypher-10 Python notebook file. So that's all about the part 5. And coming to the part 6, improvements in convolutional neural networks. So shapes are changed to 4436 uh, to 443264. Added one extra convolutional neural network convolution layer for getting better results. So including another convolution layer, pooling layer and fully connected layer, the model then uses the cross entropy loss function and the Adam optimizer to train the model. The training performed on 5,000 iterations with a batch size of 100, and the accuracy of the model is evaluated on the test set after every 100 iterations. The training accuracy is not evaluated here since it can give misleading results due to overfitting. So the accuracy of the model starts with a lower rate, 10.9% at the beginning, and the training gradually improves over time. After 5,000 iterations, the accuracy of the model reaches 67% on the test set, which indicates that the model is performed moderately well on Cypher-10 dataset. Part 4, cipher accuracy at 4,900 steps is 0.6611. Adding another CNN at 4,900 steps increased to 67%. We observe here there is a slight increase in the accuracy performance. Accuracy increased part at 4,900 is 0.0101. I have also attached the cipher with two convolutional neural networks Python notebook file to this project. So this is all about that part 6. Coming to the part 7. Part 7 is all about the project report. So this is the final project for the course Deep Learning with Big Data. In this final project, we are using the TensorFlow with versions uh, 1.150, the Python version with 3.6 for coding purposes. In this project, we are instructed to upload all the Cypher dataset files into the remote virtual machine GCP, and we will be establishing a SSH connection. We have worked on the Cypher dataset using the CNN with the TensorFlow by only using CNN layer one reshaping data being performed here. After calibrating the accuracies, we will comparing the Cypher and the MNIST data set accuracies with the CNN data 50 steps for both data sets. At the end, we have improved the accuracy of Cypher-10 dataset by adding additional layer. So describing the steps done in part 4, part 5 and part 6, similar procedures both for MNIST and Cypher. Creating the CNN with TensorFlow image classification involves the following steps. Import the necessary packages. You need to import the TensorFlow necessary packages such as NumPy, Matplotlib, and Pandas. Load the dataset. You need to load the dataset into the program. You can use TensorFlow built-in datasets or load the data from a file. Data pre-processing. You need to pre-process the data, prepare for training. This includes normalizing the pixel values, reshaping the data, and one hot encoding the label. Define the model architecture. You need to define the architecture of your CNN. This includes the defining the layers, number of filters, filter size, activation function, and the pooling method. Define the loss function and the optimizer. You need to define the loss function and the optimizer of your model. The loss function measures how well your model performing, and the optimizer adjusts the weights to improve the model's performance. Train the model. You need to train the model using training data. You can use the fit function to train the model. You need to evaluate the model performance using the test data. You can use the evaluate function to get the accuracy of the model. You can use the predict function to make predictions on new data. I changed the data step to size 15 part 5. So during the throughout the course, what I have learned is uh, understanding the basics of CNN, data processing and preparation, hyperparameter tuning, model evaluation, improvement strategies. Overall, working with Cypher10 and MNIST dataset using CNN with TensorFlow can provide a solid foundation in the fundamentals of deep learning and prepare them more advanced applications in computer vision and other fields. The performance of two convolutional neural networks models trained on different datasets, Cypher10 and MNIST, using the TensorFlow. Cypher10 model achieved accuracy of 66% after 5,000 iterations, while the MNIST model achieved accuracy 19% after the similar number of iterations. However, these accuracies cannot be directly compared since the datasets are different. The effect of adding another convolutional neural networks to the Cypher10 model, which resulted in the slight improvement in the accuracy, reaching to 67% after 5,000 iterations. This shows that adding more layers can improve the performance of the field. Uh, the project of the deep learning with big data is highlighted, and importance of the experimentation of optimizer in the development of convolutional neural networks model performed on the uh, performed on the models was found and dependent on the several factors, including the dataset used on the architecture of the model. The results of the project demonstrate the potential of deep learning models and images of the classification tasks such as achieved by the MNIST model. Overall, the project serves as a testament to the importance of deep learning in the field of artificial intelligence and its potential for solving complex real world problems. So the final part is about the final presentation video. I have provided the video link here, and I have also providing the references. So this is all about the final project presentation of ADT 5550, deep learning with big data. So these are the coding files. I'm attaching all these coding files to the project report file. Yeah, that's all about this presentation. Thank you. Bye.